Welcome back. Today we're going to talk about two variable linear systems, and specifically we're going to talk about the skill of using elimination to solve these systems of equations. So here we go, this is section 6.2. Using elimination. Elimination is going to be a process where we have the two equations and we're going to eliminate one of the variables by adding the equations together or subtracting to get rid of one of the variables. Okay, so we are eliminating, getting rid of one of the variables. Let's see how it works. First example, solve the system by elimination. We're given 3x plus 2y is equal to 4, and then 5x minus 2y is equal to 8. And what we see here is we're looking for an opportunity to add the two lines together, add the two equations together to eliminate one of the variables. And so as we kind of look here, we see this is kind of the easiest case. This is the simplest situation because if we added these two lines together, we'd end up with 3x plus 5x or 8x. These would cancel out. So you notice we eliminate one of the variables because now we don't have a y anymore. And so what we end up with is 8x equals 12. And so if we divide it by 8, we would get x is equal to 3 over 2. And so when x is equal to 3 over 2, now we can sub it back in. And so if we sub it back in over here, 3 times 3 over 2 plus 2y equals 4. What we end up with is 9 over 2 plus 2y equals 4. And so I'm going to subtract. And so 2y equals, and this is going to be negative 4.5, so minus 4.5, so negative 1/2, and we divide by 2. Y is equal to negative 1/4. Okay, and so when I subtract that 4.5 from the 4, 9 over 2 is 4.5, I get a negative 1/2, and so then I divide the whole side by 2. Half of a pizza divided into two pieces would be 1/4 of a pizza. And so my solution set takes into account these two pieces, and my solution is 3 over 2, comma, negative 1/4. Okay, so that's the simplest case when we have two coefficients that match and we can just simply do a little bit of linear combination. Here's another one. And what we notice in here is we don't have quite the situation that we want. And so what we can do is we can multiply one of the lines, and I'll show you how this works. So I've got 2x minus 3y equals negative 7. 3x plus y equals negative 5. And so here I've got a 3y, and what I'm looking for is an opportunity just to simply multiply one of the lines by some coefficient. And so check this out. I've got a y here and a negative 3y. So if I took this whole line and I multiplied both sides by 3, I would end up with, top line stays the same, bottom line becomes 9x because it's multiplying, plus 3y equals negative 15. Well, check it out. Now I can add them together, and if I add these two lines together, what I'm going to end up with is 11x, the y's are eliminated, which is what I want, I'm eliminating, equals negative 22. And so x is equal to negative 2. So if I subbed it back in, I'd go 2 times negative 2 minus 3y equals negative 7. And so negative 4 minus 3y equals negative 7. Add 4. And so negative 3y equals negative 3. So y is equal to 1. Well, so I've got this solution now. X is equal to negative 2, y is equal to 1. And so a possible solution could be negative 2, comma 1. Well, if I check it out, I put them back in, I've got 2 times negative 2 minus 3 times 1. Is that equal to negative 7? Putting it back in, checking it. Yeah, so this is negative 4 minus 3 is negative 7. Put it into the second one, 3 times negative 2. So I'm putting it into this equation. Plus 1 equals negative 5. Is that true? Negative 6 plus 1 equals negative 5. So that solution checks out. So first case, we had coefficients that matched. Second case, we multiplied one of them to get the coefficients to match. Here's another one, systems by eliminations. So what I can do is I can do a similar situation here. I've got 5x plus 3y equals 9, and then 2x minus 4y equals 14. Well, notice, I don't have an easy way to get from one to the other. Like, I can't just multiply 5x times something to get 2x. And, you know, it's a case where I might have to multiply both lines by something. And so what I can do is, I'm going to try to get my y's to match, okay? So 3 and 4 both go into 12. So if I multiplied this by 4, and I multiplied this by, say, 3, what I'd end up with is 20x plus 12y equals 36. And then on the bottom here, I'd have 6x minus 12y equals 42. Okay, and so when I combine these two lines, I'm going to add them. I get 26x equals 78. And so if I divide it by 26, divide by 26, x is equal to 3. Well, I can back substitute in. So 2x minus 4y, so I'm substituting into this one, equals 14. And so 6 minus 4y equals 14. Subtract 6. So therefore, minus 4y equals 8. So y is equal to negative 2. My solution set, 3 and negative 2. And if I checked it, I'd have 5 times 3, which is 15, plus 3 times negative 2, which is negative 6, so I got 15 minus 6 equals 9. First one checks out. Second one, 2x minus 4y, so 2 times 3, I'm subbing in my point, minus 4 times negative 2 equals 14. Well, so I've got 6 minus a minus 8, so plus 8 equals 14. So they both check out. Okay, so in that case I had to multiply. So first one I multiplied no lines. They were matching coefficients. Second one I multiplied 1 to get matching coefficients. Third one I multiplied to both lines to get 2 matching coefficients. Let's try this one. Now this one looks straightforward enough because what we end up with is we got this x here. So conveniently I'll go ahead and do this. I'm going to multiply this top line by 2 because it's going to match this bottom one. So 2 times x minus 2y equals 3. And minus 2x plus 4y equals 1. Hey, this is great. 2x minus 4y equals 6. And minus 2x plus 4y equals 1. When I add these lines together, I end up with 0x plus 0y equals 7. So 0 equals 7. This is nonsensical. And so when I end up with a nonsensical answer like this, it means that there's no solution to this system. Okay, so after you combine your lines, you got to check to see that they have a solution. If it doesn't make sense, then you are without a solution on that one. Okay, that's all there is to it, guys. We'll see you next time.